Dear friends, I am happy to see you all again with a very interesting problem on Markov chain related to dice. Let us go into the problem. A fair die is tossed repeatedly. That means I am taking a die and I am tossing the die repeatedly for finite number of times. Now, xn denotes maximum of the numbers occurring on n tosses. So what is the meaning of it? Suppose I am taking n as 5. I am tossing the die for 5 times and I am recording the output. My output are 1, 1, 3, 2, 1. Let us say now xn, here n is going to be 5. In this 5 tosses, what is the maximum number? We can see 3 is the maximum number appeared in this 5 tosses. So I will say x5 equal to 3. In general, in n tosses, suppose 3 is the number which appeared as a maximum, then I will say xn equal to 3. Hope you understand. Similarly, I will give another example. Let us consider n equal to 8 and let us record the data of the dice tossed. 1, 1, 2, 3, 1, 5, 6 and 1. Let us say. Now you see the maximum number appeared on this 8 tosses is 6. So xn, here in the case n is 8, it is going to be 6. This is what the question says. Xn denotes maximum of the numbers occurring on n trials. Now what they need, let us see. Find the transition probability matrix capital P of the Markov chain xn. So we have to find the transition probability matrix first of all. Then what is the next question? And also we have to find the probability of x2 at 6 and the matrix P square. First of all, we have to construct the matrix P. To construct the matrix P, we have to define the data one by one. Let us see. Before going into the problem, just we have to recall something. In unit 2, we have learned distributions. Throwing a die comes under binomial distribution because 4 points to remember. N is finite, then it has only success and failure. Probability of success is always constant and each trial is independent. So now throwing a die follows binomial distribution, and also if 6 occurs in the die, it will stop the occurrence of all the other numbers 1, 2, 3, 4 and 5. That means it is going to be mutually exclusive. So there is nothing common between two events in dice. For example, probability of getting 6 and probability of getting 3. Nothing is common between them. So when we go and see the problem, what is the probability of getting either 1 or 6? That means it doesn't have anything common. Probability of getting 1 is 1 by 6 plus probability of getting 6 is also 1 by 6. So there is no common between them. A intersection B is 0. So we simply write it as 1 by 6 plus 1 by 6. So why I am saying this? These things are needed for this problem. Let us keep this data in the mind and go to the problem. First of all, we have to write the state space. So the state space is going to be my 6 element. When you throw a dice, you will be getting 1 to 6. Let us construct the matrix capital P. Always we take, here it has states xn plus 1 and here we are going to take state xn. So my capital P matrix is going to be 6 cross 6. Why? Because I have 6 states. Okay, let us enter the states. Now remember that we have to fill the matrix such that always each row sum is going to be 1. So now let us take xn equal to 1. That means maximum of the numbers occurring on n trials is 1. So on the n plus 1th trial, probability of getting 1 is simply 1 by 6. Probability of getting 2 is also 1 by 6 because up to n trials it is 1. In n plus 1th trial it is going to be 1 by 6, 1 by 6, 1 by 6 and 1 by 6. Okay. Next, when up to n trials my maximum number is 2, then n plus 1th trial I cannot get the maximum number 1 because up to n trials it is going to be 2. So in n plus 1th trial getting 1 is 0. Similarly, Now we can fill the matrix. For 3 on n plus 1th trial getting 1 and 2 is 0. When up to n trials my maximum number is 4, getting 1, 2, 3 on n plus 1th trial is not possible, it is 0. Similarly, for 5 as the maximum number on n trials, getting 1, 2, 3, 4 has no chances. It is going to be 0. And similarly, 6. There is no chance of getting 1, 2, 3, 4, 5. And there is only one chance to get 6. It is 100%. It is going to be 1. Now, our job is to fill the remaining places which is left as open. So now we have to calculate the probability for these spaces. Let us see how to do this. Okay, I will explain row by row. So probability of xn equal to 2, that means up to n trials the maximum value is 2. On n plus 1th trial, what is the probability of getting 2? So when you go for n plus 1th trial, if your maximum number should be retained as 2, there is only 2 chance. A die should show either 2 or the die should show 1. So probability of getting 2 is 1 by 6. Probability of getting 1 is also 1 by 6. And nothing common between them because they are mutually exclusive. So probability of getting n plus 1 trial, the maximum number is 2, provided up to n trials the maximum number is 2 is 1 by 6 plus 1 by 6. Next one, probability of getting n plus 1th trial should be maximum value 3, provided up to n trials it is 2. So the only chances on the n plus 1th trial, the die should show 3. So the probability is 1 by 6. Similarly, for 4, the probability is also 1 by 6. And similarly for 5, the probability is 1 by 6. Similarly for 6, the probability is 1 by 6. Now let us fill the second row of the matrix. So up to n trials, the maximum number is 2. On n plus 1th trial, what is the probability of maximum number is 2? Either 1 or 2. So it is going to be 2 by 6. And when up to n trials maximum number is 2, on n plus 1th trial to get maximum number is 3, the probability is 1 by 6. For 4 also 1 by 6, 5 also 1 by 6 and 6 also 1 by 6. Similarly, now we can construct the third row. The present state, the maximum value is 3 up to n trials. What is the probability of getting maximum value 3 on n plus 1th trial is either I will get 1 or 2 or 3 when I throw. So that means the probability is going to be 1 by 6 plus 1 by 6 plus 1 by 6. It is going to be 3 by 6. When up to n trials, my maximum number is 3. On n plus 1th trial, the probability of getting 4 is unique. It is going to be simply 1 by 6. Similarly for 5, 1 by 6, 6, 1 by 6. And then we can fill the table in a similar way. Similarly for getting 4, so I had a chance either 1 or 2 or 3 or 4 for getting 4 as the maximum value. So it has the probability 4 by 6 and on n trials maximum value is 4. The next maximum value should be 5 means the probability is 1 by 6. Similarly for 6 is also 1 by 6. And then on state n it is going to be 5. The maximum value is 5. Then n plus 1th state, probability of getting maximum value 5 is 5 by 6 because you will be getting 1 or 2 or 3 or 4 or 5. So 5 by 6 and getting 6 is simply 1 by 6. And now you understand how the matrix is constructed. Now I am going to show typed version of a matrix for your clear view. First row, all the probability is going to be 1 by 6. When you come for second row, we can fill the table which we already construct. So now this is the final matrix capital P which is required. And we can see the states. Hope you understand the matrix. So now the first part of the problem is done. We found the matrix. Now we have to construct P square. Let us construct P square. So P square is going to be simply P into P. In your exam point of view, just write the two matrix and remember calculator has the limitation. It can only multiply up to 3 cross 3 matrix. When the matrix is 4 cross 4 or 5 cross 5 or 6 cross 6, then the calculator tricks will not work out. We have to do it manually. Okay. Now for this problem, just write the P matrix twice, and now we are going to write the multiplication in a simple way. Okay. So when you're going to multiply these two matrices, it is very obvious that what I'm going to get. I'm going to get 1 by 36. So I can directly write 1 by 36 outside because I don't want to multiply it. It takes huge time. Okay. So now I'm going to write the matrix. Okay. So remember, when you multiply, you are going to get the odd number 1, 3, 5, 7, 9 and 11. And we know the lower triangular matrix are going to be 0. Just now we found. So let us write this in a clear way. Now we have to fill the remaining elements. How to remember this matrix multiplication in a easier way? 1 plus 3 is 4. Right? Remaining elements you write as it is. It's going to be 5, 7, 9, 11. And when you come for the third row, it is going to be 5 plus 4 is 9. Okay. Then fill the remaining elements as usual. 7, 9, 11. Then when you go for the fourth row, 9 plus 7 is going to be simply 16. Then you write the remaining data as usual, 9, 11. Then 16 plus 9 is going to be 25, and write the remaining element 11. And finally 25 plus 11 is going to be 36. When you divide by 36, it is going to be 1. So this is my P square matrix. So we did the P square matrix. So we finished the second part of the problem which they have asked. Now we have to do the first part. So to do the first part, we need the initial matrix, initial state of the probability distribution. It is very obvious. We know at the initial state the probability for each element is going to be simply 1 by 6. So the next part we have to find is probability of x2 is equal to 6. Do you remember, students? It is pure probability. So at 2 state 6. So now I have to construct, or I have to find this P2. We know that small p0 is going to be this. Now I want to find P1. P1 is nothing but P0 into capital P. Similarly, P2 is nothing but P1 into capital P. So we have the capital P, that is my transition probability matrix, and we have P0. So we have to construct P1 and finally P2. When I construct this, I have to go to state 6 and I found the value. Let us see. So this is my P. So my P1 is going to be P0 into capital P. Therefore, P1 is going to be P0, that is the row matrix 1 by 6 into capital P. So the answer is going to be very simple. When you multiply this, the first row is going to be 1 by 36. Then when you multiply this first row with the second column, we are going to have 1 by 36 plus 2 by 36. It's going to be 3 by 36. Similarly, for the first row with third column, we are going to get 1 plus 1 plus 3. It's going to be 5 by 36. Similarly, first row with fourth column 1, 1, 1, 4. So it is going to be 7 by 36, and the next one is going to be 9 by 36, and finally we have this one, I can take it as 6 by 6. So finally the last one we have, it is going to be 11 by 36. So this is going to be my P1. Next what I have to do, I have to find P2. P2 is nothing but P1 into the matrix capital P. Let us do the multiplication. So let us find P2. P2 is P1 into P. So the row matrix into capital P. So my answer is going to be first row. When I multiplied with the first column, I am going to get 1 by 216. First row with second column. Now 1 into 1, 1, 2 3s are 6. So 1 plus 6 is going to be 7. Then first row with third column, we are going to get 1 into 1, 1 into 3, 3 into 5. So 15 plus 3 plus 1, it is going to be 19 by 216. Then first row with fourth column, similarly when we multiply, we'll be getting 37 by 216 and 61 by 216 and finally 91 by 216. So this is my answer. So let us write in a proper way. So let us write P2 separately. Now this is the answer. We have to find probability of x2 equal to 6. It's pure probability. As we said, P2 at state 6. So from the above data, we know the states are 1, 2, 3, 4, 5, 6. P2 state 6 is going to be 91 by 216. So this is the answer for the first part of the problem. Hope you understand, students, and happy to see you with this new problem. Good luck. Like our channel, subscribe, share to your friends, give your comments. Thank you. We'll see you in the next video. Bye bye.